Hello everyone and very good morning. So today in the class we are going to revise questions of ray optics. Done it? Through questions we will be revising concept mostly. But yeah, some formula I have just written over here just to remind you of things. So let's get started without wasting any time. What is the mirror formula? So in case of mirror, we studied concave mirror, convex mirror, plane mirror. So for all these three kind of mirror, if we have to calculate image distance for object distance given and focal length given, we can apply this formula. Magnification is minus p by u. For lens formula, this is the object image distance relation thing, and this is the magnification formula. Then there is one important formula which is lens maker's formula, which talk about the focal length of lens. It is equal to lens focal length of lens, refractive index of lens minus 1 divided by refractive index of, sorry, there is a mistake here. This won't be M1 actually. It will be your mu L minus mu M divided by mu M 1 by R1 minus 1 by R2. So what does it mean? इसको हम ऐसे भी लिख सकते हैं refractive index of lens with respect to media minus 1 into 1 by R1 minus 1 by R2. Now, what is this R1 and what is this R2? So, if you are given a lens, any lens, let's say this is the lens you are given. So, which will become R1, which will R2? Simply allow a ray of light to fall on it. Let's say I'm allowing light to fall from the left direction. So, whatever fall in the direction of light, incident light, will be taken as positive. So here you see this surface, this curved surface is a part of a larger hemisphere, you can say, and it will have center somewhere. So its radius of curvature is something R1, and we measure from optical center. So if we measure from optical center R1, it is getting measured in the opposite direction of the incident light. That is in this direction we are measuring, okay? Because center is here. So R1 we will measure towards left. Okay, so this R1 here will become this one will become R1. R1 is that surface on which light is incident light is falling, and which will be R2, the other one. So from here light is getting refracted, but ये diagram मैंने गलत बनाया है because this is a concave lens. Light will get refracted something like this. ठीक है? So इसका अगर आप center देखो, इसका center will be somewhere here, and if you measure R2, you will be again measuring from optical center in this direction, in the direction of incident light. So here R1 is this, R2 is this, R1 is negative, R2 is positive. So that is how you will be keeping things in lens maker's formula. This is a very important formula. यहाँ से बहुत सारे questions बनते हैं, ठीक है? इसके बाद मैंने एक कॉमन चीज इंक्लूड कर लिया है, दैट इज माइक्रोस्कोप, कंपाउंड माइक्रोस्कोप एंड टेलीस्कोप। इसके फॉर्मूलाज को हम रिवाइज कर लेते हैं, क्योंकि रे ऑप्टिक्स में ऐसे तो बहुत सारी चीजें हैं, नॉट ऑल वी कैन रिवाइज एंड देन डू क्वेश्चन, सम वी विल रिवाइज, आफ्टर दैट वी विल डू क्वेश्चन, थ्रू क्वेश्चन वी विल बी लर्निंग द लेफ्ट कॉन्सेप्ट्स, ठीक है? So magnification by simple microscope first we will see. So simple microscope has only one lens, and that is which sort of lens? That is your convex lens. Okay, so simple convex lens can be called a simple microscope. And for this, how we define magnification? Magnification will be equal to d by f if final image is getting formed at the infinity. Okay, so object is kept somewhere here, somewhere between what? I mean, object is if final image is getting formed at infinity, object is at, you can say it is at f, right? So let's not go into all those discussions because we have done this in class. Now we need to focus on the final result. So final result is that if for simple microscope, it is given in the question that final image is getting formed at infinity. Then tell me the magnification. So magnification will be d by f, where d is the D is the distance of normal adjustment. जहां से अगर आप बहुत close object को कर दो, then you won't be able to see it. So d is that distance basically. Magnification is d by f. And then there is another case when image is at near point. Here d was your near point. D was what? Near point. Now, I mean, first case क्या था? When final image is getting formed at infinity, And second case is when image is at near point. So when image will get formed at near point, that is object is somewhere here, it must be between focal length and optical center, then only final image is getting formed. Final image getting formed is virtual, and it is getting formed at a distance d on the same side of the lens. And here magnification, we have done the calculation, that will be equal to 1 plus d by f. So this is equal to 1 plus d by f. Magnification here is greater by 1. So which is the, more suitable case? So if you look here, here final image is getting formed at infinity, and in the second case, at least distance of distinct vision, that is at near point, right? So जब भी कोई चीज infinity पे होता है, then more, it's more relaxed way to look at those things, because जैसे आप साइट सीइंग करने जाते हो, you look at mountains, you look at trees far away, आपकी आंखें थकती नहीं है, but when you are reading a book sitting in a room, your eyes start feeling the stress. Why? Because book we are reading which is kept at a distance near about uh, d, right? So जब आप ऑब्जेक्ट को यहाँ, जब आपकी फाइनल इमेज जो बन रही है, if it is getting formed at a less distance of distinct vision, आपको आपकी आंख यहाँ ऐसे है, and you are looking at this thing. And so this is not formed at infinity. This is getting formed at a near point. And here on your eye, there will be stress. So in this case, though we are getting magnification 1 greater than that of the relaxed state, that is when final image is formed at infinity. But this is not the desirable thing that that we will go for, because यहाँ पे eyes पे stress काफी ज्यादा आता है. So we opt for simple microscope, which will form final image at infinity, though their magnification is less. ठीक है, चलो. So दोनों केस में हमने पढ़ा. कंपाउंड माइक्रोस्कोप में क्या होता है? नाउ इन सिंपल माइक्रोस्कोप वी कैन नॉट अचीव मोर मैग्निफिकेशन, because there is only one lens to magnify things. In compound microscope, what we do, we take two convex lenses so that we can have more magnification. Again, ये इस लेंस को आप क्या बोलोगे? जिस लेंस के सामने ऑब्जेक्ट होता है, that lens is called objective lens. So this is your objective, and another one is eyepiece. यहाँ पे ध्यान से देखना, ऑब्जेक्टिव की साइज इज स्मॉलर देन दैट ऑफ आईपीस का साइज, एंड दिस थिंग वी टेक बिकॉज यहाँ पे जो भी आप ऑब्जेक्ट रखोगे, मैग्निफिकेशन का मतलब, कंपाउंड माइक्रोस्कोप क्या करता है? स्मॉल चीजों को लार्ज करता है. ठीक है, सो इफ यू आर कीपिंग स्मॉल थिंग ओवर हियर, देयर its dimension is already very small, so less number of radiations are coming out. ठीक है, and if less numbers are radiations are coming out, then radiations participating in forming the image of this smaller object is not that much. So image getting formed is not that, won't be that bright. और अगर हमने यहाँ पे बड़ा सा ऑब्जेक्टिव लेंस ले लिया, then light will scatter more. ऐसे भी लाइट कम है और वो और ज्यादा स्कैटर कर गया, then intensity will decrease even more. ठीक है, that is why what we do is we take objective of smaller aperture. इसका aperture क्या होगा? Smaller होगा. Now let's talk about the let's talk about magnification. ठीक है, so magnification यहाँ भी दो cases होंगे. In one case, final images will get formed at infinity, and in another case, final images will get formed at the least distance of distinct vision. Again, the case where final image is getting formed at infinity, that case is more desirable because there eye पे stress नहीं होता है. ठीक है. Now in first case, where the what will be the magnification? अगर आप magnification देखो तो यहाँ पे magnification will be because of two lenses. One because of objective lens and another because of eyepiece. यहाँ पे एक चीज ध्यान देना, सबसे पहले मैग्निफिकेशन के साइन पे आ जाओ आप. व्हाट विल बी द साइन ऑफ मैग्निफिकेशन? पॉजिटिव और नेगेटिव. सो इनिशियल ऑब्जेक्ट इज above principal axis, and final image getting formed is below the principal axis. So object or image, their one is upright, another is inverted, so magnification total has to be negative. ठीक है, ये चीज याद रखना. उसके बाद लेट्स कैलकुलेट द मैग्नीट्यूड. सो मैग्निफिकेशन बिकॉज ऑफ आईपीस विल बी सेम एज the way we calculated magnification because of simple microscope. So if final image is getting formed at infinity, ME will be equal to D by focal length of eyepiece, that is FE. What will be magnification of M naught? That is because of objective lens. So that will be equal to formula आप use कर लोगे. This is distance of the object, let's say, and let's say the image, first image getting formed is at a distance V naught. So M naught का value आप क्या लिखोगे? V naught by U naught. So this will give you the total magnification. ठीक है? Done it. So and the case where final image is getting formed at least distance of distinct vision, here also again overall magnification will be negative, but here magnification because of eyepiece will become 1 plus d by fe, same as simple microscope. Eyepiece is acting same as simple microscope. M naught will be equal to what? Here with proper sign it has written minus v naught by u naught. ठीक है, क्योंकि यहाँ पे देखो u naught with proper sign convention will become minus u naught, v naught will be plus u naught. यहाँ मैंने मैग्नीट्यूड सिर्फ लिखा क्योंकि साइन की बात मैंने पहले ही कर रखी थी, इट विल बी नेगेटिव, सो ओवरऑल यू कैन पुट हियर नेगेटिव साइन. ठीक है, चलो. सो दिस वाज योर सिंपल माइक्रोस्कोप. नाउ व्हाट अबाउट द टेल. यहाँ पे ऑब्जेक्टिव का अपर्चर बड़ा होता है बिकॉज वी आर लुकिंग एट अ स्टार्स. सो टू लुक, टू फाइंड अ स्टार्स bright in our eyes, we need more light coming from here to enter the lens, and more light will only enter if aperture is larger. ठीक है, because for sun or any star there is no scarcity of rays coming out of it. There are so many. Only challenge is how many rays we are able to capture. So we make objective lens का aperture bigger. ठीक है, this is your eyepiece. Let's come back to the final formula. So final formula तुम्हारा होगा f naught by fe. Again sign क्या होगा magnification का negative, because you see incident light is coming somewhere from here. So object feels like it is perpendicular to the principal axis and vertically upright. Then and image is getting formed somewhere below. So image, final image formed is inverted. So magnification here also has to be negative. Then we define tube length of the what? Of the telescope, and that is equal to f naught plus fe. Overall tube length microscope का पूछे या telescope का पूछे, tube length is basically distance between this, and this can be approximated to be equal to f naught plus fe. Here it is exactly f naught plus fe. क्यों? क्योंकि initially object is at infinity, image will get formed at the focal length of objective, that is this is f naught. And if final image is also getting formed at infinity, this it means this is also the focus of second length. So this is also fe. So f naught plus fe tube length. ठीक है, चलो. Now we will be doing questions. अब आप time लो and do questions. Very good. One correct answer I got, Shruti. Yes. Yes, come on, everybody. So I've ended the poll. What is the statement one? Image formation needs regular reflection or refraction. Yes. For image formation, we either need light to get reflected or either we need light to get refracted. So statement one is what? Statement one, yes, Raju, correct. Statement one is correct, right? क्योंकि हमने इमेज फॉर्मेशन पढ़ा है थ्रू रिफ्लेक्शन एंड रिफ्रैक्शन, then only we learn about image formation, right? Statement 2, the variety in color of objects we see around us is due to the constituent colors of the light incident on them. Yes, जैसे कलर हमें कैसे दिखता है, देखो यहाँ पे ऑब्जेक्ट है, लाइट इज फॉलिंग ऑन द ऑब्जेक्ट एंड वॉट एवर कलर ऑफ लाइट इज गेटिंग रिफ्लेक्टेड, done it, that reflected, I mean if this reflected light has a color of yellow, then we will see this object is yellow. ठीक है, so the variety in color of objects we see around us is due to constituent colors of the light incident on them. So here light is incident, it has different colors, and particular color is getting reflected here, and that color we are able to see. So statement 2 also fills what? Correct. ठीक है, so correct option will be what? Both statement 1 and statement 2 are correct. ठीक है, चलो now let's do this question. Okay, I got some answers. 2 feels correct, 1 seems incorrect. Great. Okay, let me end the poll now. चलो सॉल्व करते हैं. प्रिज्म में what are the things that you need to have in mind? सबसे पहले मैं फॉर्मूला बता दूं. So प्रिज्म जब ऐसे करते हो, if you allow one light to incident on one surface, then light will get refracted by certain angle r1, then again incident on second surface. Let's say here the angle of incidence is r2. डायग्राम मैंने बहुत ज्यादा छोटा बना दिया, so let me erase everything. जैसे ऐसा है तुम्हारा केस, light is incident like this, it is going like this, then coming out like this. So here, this is the second, I mean, this is the angle of incidence on the first surface, I. This is angle of refraction, and this is angle of incidence on the second surface, and this is angle of emergence. So what are the formulas we have studied? This angle is called angle of prism, indicated by letter A. So first thing is R1 plus R2 is equal to A. Then we define angle of deviation of prism, that is delta is equal to I plus E minus A. And after that, we can apply Snell's law at any surface to calculate whatever things are given. So now we are going to apply Snell's law over here to calculate the required thing. What is given here? There is a light incident at an angle 30 degree on surface AB. And you can see here, angle of prism is given to be 90 degree. And on the second surface, if you notice, angle is getting refracted by an angle of 90 degree. So E is equal to 90 degree here. We don't know R1, we don't know R2, but we know one thing, that R1 plus R2 is equal to A, and that is equal to here 90 degree. So these two things are going, this thing is clear. Okay? We have to calculate refractive index of the prism. Let's do one thing. Let's apply Snell's law at the point P. So if we write Snell's law at point P, refractive index of air we will take as 1, because nothing else is getting talked about the media here, or media in which prism is kept. So let's write here the Snell's law. 1 into sine 30 will be equal to, light is getting refracted inside the prism. So it will become sine R1 into refractive index of prism. So sine R1 will be equal to how much? 1 by 2 mu. ठीक है. Now if we apply the same Snell's law at surface 2. Here, let's apply the Snell's law. So here you will write angle of incidence is R2 and incident light is in medium mu. So mu sine R2 is equal to refraction is happening in air media. So refractive index 1 into sine angle of refraction 90 degree. So here you can see mu sine R2 is equal to what? 1 by mu. एंड साइन R2 को आप क्या लिख सकते हो? R2 को क्या लिख सकते हो? 90 माइनस R1. So sin 90 minus R1 is equal to 1 by mu. So from here you can clearly see cos R1 is equal to 1 by mu. You can calculate sin R1. ठीक है, sin R1 आप कैसे निकालोगे? 1 minus cos square R1 का root under. So this will become 1 minus 1 by mu square root under. So this is mu square minus 1 by mu. ठीक है. Now put the value of sin R1 over here. So this is mu square minus 1 by mu. Square कर दो दोनों side. This will become 4u का square. So yes, it will be like this. ठीक है. If you see here, 1 mu you will get cancelled, 1 mu, and this is okay. कहीं calculation में कुछ तो error जा रहा है. What is the error? Can anybody locate it? Can anyone see the error? मुझे दिख नहीं रहा. क्या गलत जा रहा है ये बताओ. यहाँ से देखो साइन 30 को हाफ लिखते हैं ना हम. साइन R1 इंटू म्यू. सो साइन R1 इज इक्वल टू 1 by 2 म्यू. राइट. दिस विल बी द थिंग. LCM इज म्यू स्क्वायर. ओके. अच्छा ये म्यू स्क्वायर होगा. लेट्स चेक वंस मोर. तो साइन R1 के वैल्यू को मैं क्या लिख रही हूँ? म्यू स्क्वायर माइनस 1 बाई म्यू इक्वल टू 1 by 2. ठीक है. स्क्वायर कर रहे थे ना. दिस विल आल्सो बिकम स्क्वायर. तो ये इसको कैंसिल कर दो. दिस विल बिकम 1 by 4 if we are squaring on both sides now. Then this will become how much? Mu square minus 1 is equal to 1 by 4. So mu square is equal to 5 by 4 and mu will be equal to how much? Root under 5 by 2. So correct option will be your option 2. ठीक है. Now let's move on to the next question. Done है. चलो ठीक. Now let me know the things. Yes, Shruti, it feels correct. Okay, two of you got it correct. Others, please let me know the answer. You just need to put in the formula. Magnification of telescope का formula क्या था? Minus f naught by fe. So if we talk about just the magnitude, it is f naught by fe, right? And here focal length क्या दिया हुआ है? Objective lens का 140 centimeter. What is the eyepiece focal length? 5. So if you 5 centimeter, right? So if you divide it, how much it will become? 2, 8. So answer is going to be B, right? Chalo, now do this question. I got three answers so far. One is correct, two are incorrect. See more carefully. Look at how many focal lengths you can get. As many focal lengths you will get, that many of images will be formed. Simple. So just try to have a check of focal lengths. So if you see here carefully, आप ध्यान से देखो, there is this upper portion which has a different focal length. Then there is this portion which has a different focal length. And then this is this bottom region which has a different focal length. ठीक है? Both these three regions have different focal lengths. Let's say this is mu1. Let's say this is mu. Let's say this is. Now, how image will get formed? See here, यहाँ से जो भी rays निकल रहे, some rays may get refracted by this portion, some rays may get diffracted by this portion, some rays may get refracted by this portion. So three reasons है. And if the ray of light is refracting through this region, then it will have different focal length for that portion. Why? Because you just see the lens maker's formula. Lens maker's formula हमें क्या बोलता है? Refractive index of lens with respect to media minus 1 by R1 minus 1 by R2. So if you see here, this whole portion, let's say this part of the lens has a radius of curvature R1. So this has a radius of curvature R1, this also R1, this also R2. Okay? But if you calculate focal length for the upper region, this region, 1 by f1 will be equal to mu lens. Mu lens is your how much? Mu1 by mu media minus 1. Okay? And 1 by R1 minus 1 by R2. So that is the focal length we will be getting if light is passing to the upper region. If we talk about the middle region, then through middle region, focal length will be different because mu lm will change. And here mu lm will be what? mu2 by mu media. Media is same, right? Media कहने का मतलब where you are keeping the lens. So we have kept lens in air. Let's say in air we are keeping the lens, and this lens has upper region with focal with refractive index mu1, middle range with mu2, and bottom range with mu3. And then we are calculating focal length. So if you write here 1 by f2, 1 by f2 will be equal to what? Mu2 by m minus 1, and this is 1 by r1 minus 1 by r2. So this thing is changing. Done it? And if this thing is changing, we will be getting three different focal lengths. And if there are three different focal lengths, then for the same object distance, let's say object is kept here and light is going through this region, then 1 by v minus 1 by u, आप क्या लिखोगे? 1 by f1. U is same in all the cases. So 1 by v will be equal to 1 by f1 plus u. With proper sign convention, we will keep the value of u, right? So this is this. In second case, image distance will become 1 by f2 plus 1 by u. In third case, it will become how much? 1 by f3 plus 1 by u. So image distances are different in three cases. So at 3 points, we are going to get image. It means 3 image, right? So correct answer will be what? D. Okay? Now let's move ahead. Let's do this question. जो कल मैंने फॉर्मूला स्पीड ऑफ लाइट का बताया था ना, रिलेटिव परमिटिविटी एंड परमिएबिलिटी को रिलेट करके, दैट फॉर्मूला विल बी इफेक्टिव ओवर हियर. सो डू इट. यहाँ पे क्या क्या फॉर्मूला तुम्हें यूज आएगा? सो फॉर्मूला रिवाइज करवाना मेरा टास्क है. तो यहाँ पे देखो, स्पीड ऑफ लाइट को हम कैसे लिखते हैं? 1 बाई म्यू एप्सिलॉन. If we talk about 3 into 10 to the power 8, then this is mu naught epsilon naught. Otherwise, in any other media, it is written as mu epsilon. And how we define refractive index of media? Refractive index of media is defined as speed of light in vacuum divided by speed of light in media. Like this. Okay? So use the formula and let me know what answers you are. I have launched the fresh poll. You can answer over there. Anyone? No answers? कैसे कर रहे हो तुम लोग? If epsilon naught and mu naught are the electric permittivity and magnetic permeability in a free space. So in free space, it is this, and 2 epsilon naught and 1.5 mu naught are the corresponding quantities in a media. So in the media, epsilon is becoming 2 epsilon naught and mu is becoming 1.5 mu naught. Okay? Then we have to calculate the refractive index, the index of refraction of the media, what it will be. So if you write speed of light in vacuum, that will you will write as root under epsilon naught mu naught, because it is given epsilon naught and mu naught are electric permittivity and magnetic permeability in a free space, means in vacuum. See this. What will be the speed of light in the media? So speed of light in the media will be epsilon mu. And what is the value of epsilon here? That is your 2 epsilon naught into 1.5 mu naught. So this is equal to how much? 1 by 3 epsilon naught mu naught. Now, if you calculate refractive index, then refractive index is what? C by V. So you will write here 1 by root under epsilon naught mu naught into V का value क्या है? 1 divided by root under 3 epsilon naught mu naught. So that will give you how much? Root under 3. Correct answer will be what? It should be B, right? Getting me or not? Okay, 3 answers. One is correct. 3 आएगा, है ना? So correct answer is your what? It is this one. Please remember these formulas. Now let's do this question. Very good. I got 2 correct answers. That's great. Everyone, please come forward. You just need to have a slight idea of how we do this. Yeah. Okay, let me end the poll now and then we will be discussing it. So if you see here, this ray of light is entering horizontally. It means what? Here angle of incidence is 90 degree. Angle of incidence is, so I is 0. Here R1 will be what? 0. So the ray of light will go like this. Okay, this is also 90, it means. And if this is 6 degree, this will become how much? 84 degree. And if this is 84, then this is normal on the second surface. So this hole is a 90 degree. This is 84. This will become how much? 6 degree. So angle of incidence on the second surface is how much? 6 degree. Now apply Snell's law at this point. If you apply Snell's law, what will be the thing? Sasan, yes, very good. So if you apply Snell's law, क्या लिखोगे आप? A mu, that is 1.5 into sine 6 degree is equal to how much? Is equal to sine E into refractive index of media 1. So स्मॉल एंगल के लिए हमने क्या पढ़ा है? साइन थीटा को वी कैन राइट एज थीटा इफ द एंगल इज स्मॉल, राइट? सो हियर कितना स्मॉल? इफ थीटा इज लेस देन 10 डिग्री, 6 डिग्री इज लेस देन 10 डिग्री, so we can write sin 6 degree as 6. ठीक है? So that is equal to sin E. So this is 9, and here E will be also a small angle since angle of incidence is smaller. So sin E को भी E लिख सकते हैं हम. Done है? So E will be equal to how much? 9 degree. So E का आंसर कितना आएगा? 9 degree. How we did it? We only took in consideration small angle thing. For a small angle, sin theta is approximated to be theta. How much is small? Less than 10 degree. ठीक है? So for this, we calculated this one. Also small angle, अगर तुम्हारा प्रिज्म स्मॉल होता है, जैसे ये वाला एंगल अगर स्मॉल होता है, एंगल ऑफ प्रिज्म, इफ दिस इज लेस देन 10 डिग्री, देन डेविएशन को हम और कैसे लिखते हैं? म्यू माइनस 1 इंटू ए. You should remember this mu is refractive index of lens with respect to media. ठीक है? So this is refractive index of prism with respect to media. This one and this into a. When we use this deviation formula, when angle of prism is smaller, otherwise deviation का formula क्या है? I plus e minus a. ठीक है? चलो. Now let's do this. You can vote in the poll if you have got the answer. Very good. I got one correct answer. That's great. Okay, let me end the poll now. If you see question or read question carefully, there is an object mounted on a wall. So on a wall, there is an object. If the image of equal size is to be obtained on a parallel wall, image of equal size, here there is object, and here we have to get the image of equal height with the help of a convex lens. So if you remember, for a convex lens, when we get same height of image, for what position of object? If object is kept at what? At a distance 2r, that is no, at a distance 2f, right? At a distance of radius of curvature. So if it is kept at a distance of 2f, we will get image again at a distance 2f on the other side, and image will be inverted. Okay? And here also with the help of convex lens we are doing this. I think एक बार check करो. Here also with the help of convex lens we are achieving this. So if convex lens is kept here and this is the object, this is the image. It means from here this distance is equal to 2f and also this distance is equal to 2f. Now what else is given? The lens is kept at a distance x in front of the second wall. So second wall से कितने distance पे रखा हुआ है x. यानी कि 2f किसके बराबर है x. यानी कि focal length क्या है x/2. सिंपल. तुम्हें लॉजिक याद रखना था कि ऑब्जेक्ट के हाइट का इमेज कब बनता है व्हेन वी गेट सच सॉर्ट ऑफ इमेजेस. सो वी गेट image of equal height as that of object when object is kept at the center of curvature of the lens, that is at a distance 2a from the optical center. And in that case here image will be also getting formed at another center of curvature. Okay, on the other side. So here 2f is given as x, so x is, so f is x/2. Okay, sure. Now do this question. पे x in time t1 है, ठीक है, and then 10x in time t2, ठीक है. Okay, let me explain this to you. Light travels a distance x in time t1. X distance it is covering in time t1 in air. ठीक है? So in air speed of light क्या हो जाएगा? Speed of light in air को क्या लिखोगे? x by t1. ठीक है? And 10x in time t2. Just give me some seconds. Yes. So 10x in time t2. So in time t2 in another denser media, this is a denser media, okay? And here it is covering 10x distance in time t2. So speed in the denser media will be equal to how much? It will be 10x by t2. Now what we have to calculate? Critical angle. What is critical angle? If you know about critical angle, then there is one denser media and there is one rarer media, right? In order to calculate critical angle, we allow light to fall from denser to rarer media. So let's draw the normal, and this is your denser media. This is your rarer media. Light will refract away from the normal. So in this case, light will refract like this. And as you will keep on decreasing or increasing the incident angle, let's say we are increasing incident angle, then what will happen? It will refract more towards this axis. And for a particular angle, this angle of this refracted light will graze the surface, and angle of refraction we will get as 90 degrees. So for the angle of incidence, incident on the denser side, for which we are getting angle of refraction equal to 90 degrees, that angle of incidence that is critical angle. Okay. Now let's define this critical angle. So if we apply Snell's law at point O for critical angle thing, then let's say this is the critical angle I. ठीक है. So refractive index of denser media into sin IC will be equal to refractive index of rarer media. ठीक है. Here it is air into sin 90. Now put the values. So refractive index of denser media क्या होगा ये बता. Refractive index of denser media क्या होने वाला है? Mu d. That will be equal to speed of light in vacuum divided by speed of light in denser media. So that is 10x by T2. So this is equal to C T2 by 10x and this is equal to sin IC. And mu air will be equal to what? Mu air अगर आप निकालोगे still speed of light in vacuum divided by speed of light in air. So this is equal to x by T1. So this is equal to C T1 by x into 1. X will get cancelled. C will get cancelled. So sin IC is equal to how much? 10 T1 by T2. ठीक है. So here IC will become how much? It will become sin inverse 10 T1 by T2. So correct answer will be your third one. Okay. So this is how we calculate things. This was a good application of how we calculate refractive index. What is critical angle? How we write it. So this is a good question in terms of revising the concept. Now let's do this. Hello, I will make you understand this question. It is talking about combination of lenses. If you think here, there is one lens kept here, done, and then there is this thing here, and then there is this thing here, done. There is a liquid in this region. There is liquid in this region. Maybe there is glass in this region. Okay. So how many lenses we can notice here? One lens is looking like this. And then third lens is like this. है या नहीं है बताओ. Third lens is like this. So when it is talking about calculating the combination of focal length of combination of lenses, what you have to do, you have to individually calculate focal length of this one, then focal length of this one, and then focal length of this one. And then you have to utilize the formula 1 by f equal to 1 by f1 plus 1 by f2 plus 1 by f3. So this is what you are going to done. How you will calculate 1 by f1? अब चलो एक काम करते हैं. अगर यहाँ पे देखो, let's say its radius of curvature is r, then also its radius of curvature is r, also this radius of curvature is r, also this radius of curvature is r. I have told you to use the lens maker's formula. First take a incident light. So here I am taking incident light like this. ठीक है? So for first lens, second lens, third lens, this is the direction of incident light. So whatever is in this direction, that we will take as positive. Whatever is in this direction, that we will take as negative. Now let's calculate 1 by f1. So that is equal to refractive index of lens with respect to media. So basically this whole thing is kept in what? It is kept in air. Nothing is given about the media. So we will say it is kept in vacuum. Okay. So refractive index of this lens with respect to media will be how much? Basically mu L minus 1, because refractive index of media is 1. So mu L by mu M karoge. So mu M is 1. That will remain as mu L. This 1 by R1 minus 1 by R2. So if we talk about first lens, mu L is your how much? That is 1.6. This is minus 1. And this will become how much? If you see here, 1 by R1. Now this is the R1. Its radius of curvature will be how much? This is a flat surface. Its radius of curvature is infinity. So this is 1 by infinity minus R2. So इसका R2 देखो, इस surface का R2 किधर होगा? कहीं इधर, इसका center है. यानी कि this way you will measure the distance positive. So here 1 by R. And if you will calculate it, you will get 0.6 by, ठीक है? So this is what we are going to get. R value is also given. So let's put it. R is equal to 20 centimeter. Okay. So if you put it here like this will become how much? Minus 3 by 100. Okay. This is your how much? Minus 3 by 100. Similarly, if you go on to calculate 1 by f2, 1 by f2 आप कैसे लिखोगे? Let's talk about the middle lens, this one. So refractive index of lens is how much? That is 1.5. So 1.5 minus 1 into 1 by R1 minus 1 by R2. So इसका R1 देखो, ये वाला surface है. R1 is in this sense. So positive R, and R2 will be in this sense. है ना? इस surface का center किधर होगा? इधर होगा. So you will measure in this direction. So this is going to be minus R, this, and this will become how much? 0.5 into 2 by R, that is 20. So if you solve it, you will get something 100, and then this is something 0.5 by 100, right? Sorry, 5 by 100. So let's write it 5 by 100. Then what will be 1 by f3? That will be same as this lens. है ना? क्योंकि दोनों ही सेम लेंसेज है, दोनों का फोकल लेंथ सेम होगा. Minus 3 by 100. Now what will be the answer? If you see here, we have to do 1 by f1 plus 1 by f2 plus 1 by f3. 1 by f1 plus 1 by f3 is how much? Minus 3 by 100. Minus 3 by 100. 1 by f2 is how much? 5 by 100. So 5 by 100. Minus 3 क्या हो जाएगा? Minus 6 by 100 plus 5 by 100. So this is equal to minus 1 by 100. And minus 1 by 100 is 1 by f equivalent is minus 1 by 100. So f equivalent will be equal to how much? Minus 100. So correct answer will be your 2. So this is how we can solve combination of lenses. Whenever combination of thin lenses are given, equivalent formula is what? 1 by f1 plus 1 by f2 plus dot dot. But remember that all focal length you have to take with proper sign convention. You cannot simply keep the sign convention out and then solve it. You will get the wrong answer. ठीक है? So overall इस क्वेश्चन में ये भी पूछ सकता है कि जो तुम्हारा कॉम्बिनेशन ऑफ लेंसेज है वो डाइवर्जिंग है या कन्वर्जिंग है. तो कन्वर्जिंग लेंस का फोकल लेंथ क्या होता है? पॉजिटिव. डाइवर्जिंग लेंस का फोकल लेंथ क्या होता है? नेगेटिव. हियर वी आर गेटिंग नेट फोकल लेंथ माइनस. इट मींस दिस कॉम्बिनेशन इज एक्टिंग एज अ डाइवर्जिंग लेंस. ठीक है? सो क्वेश्चंस बहुत तरह से हो सकते हैं. नाउ लेट्स डू दिस. डन है. अगेन कॉम्बिनेशन ऑफ लेंसेज. क्या होगा आंसर? जल्दी से बताओ. इसको सॉल्व करने की भी जरूरत नहीं है. ठीक है? Let me launch the poll and you all will be answering आंसरिंग इन वन गो? क्या होगा आंसर, बताओ जल्दी से। Two thin lenses, one is concave, another is convex. Both are having the same focal length value. What will be the combination of what will be the focal length of combination of lenses? That is the question. Okay, I got two correct answers, one wrong. How you will solve it? 1 by f equivalent is equal to 1 by f1 plus 1 by f2. फोकल लेंथ ऑफ कन्वेक्स लेंस के लिए क्या लिखोगे? 1 by f. फोकल लेंथ ऑफ कनकेव लेंस के लिए क्या लिखोगे? 1 by minus f. Because one साइन कन्वेंशन के साथ यूज करना है. One is converging, another is diverging. So this is how much? 0. So 1 by f equivalent is 0. It means f equivalent is what? Infinity. So these two combined will become what? A planar surface. ठीक है, जैसे ऐसे देख लो, ये लेंस है और ये लेंस है. इसको ऐसे अगर आई मीन एक लेंस मिला, somehow it is becoming planar because focal length of equivalent is coming at infinity. एक और लेंस ऐसे रखी तो भी क्लियरली नहीं दिख रहा, बट या यहाँ पे इक्वेशन के अकॉर्डिंग हमें फोकल लेंथ क्या नजर आ रहा है? इट विल बी infinity. So correct answer will be your third. ठीक है, this is the last question basically and I wanted each one of you to think over it. एक बार इसको कर लेते हैं, then we will leave. ठीक है, just it will take you some 1 minute क्योंकि you just have to read the question and put in the formulas, so you can do instantly. आई होप तुम लोग मीनिंग समझ रहे हो. नॉर्मल एडजस्टमेंट का मतलब क्या होता है? इसका मतलब होता है फाइनल इमेज एट इंफिनिटी. ठीक है, नॉर्मल एडजस्टमेंट का ये मतलब होता है. नाउ फोकल लेंथ ऑफ ऑब्जेक्टिव इज गिवन एंड आईपीस इज गिवन. वी हैव ऑलरेडी सीन द फॉर्मूला टेलीस्कोप के केस में. व्हेन वी आर लुकिंग एट फार अवे ऑब्जेक्ट, object distance is already infinity, and here final image is also getting formed at infinity. So for this case only we have learned the formula, and their magnification is how much? F naught by Fe with negative sign, right? So F naught क्या है तुम्हारा? F naught is 20 मीटर. ऑब्जेक्टिव का फोकल लेंथ डेफिनेटली ज्यादा होगा एंड Fe is how much? 2 सेंटीमीटर. So 2 सेंटीमीटर को मीटर में कन्वर्ट करो. You will write it like this. So 1000 with negative sign. Magnification will be this much. Distance between objective and eyepiece, that is the tube length it is asking about, F naught plus Fe. ठीक है, यहाँ पे कोई साइन कन्वेंशन लगाने की जरूरत नहीं है because you're simply measuring the distance. So 20 plus 2. And this 2 is in centimeter, this is in meter. So this will become how much? 20.02 meter. Done it? The image of planet is erect and diminished? No. इमेज हमारा कैसे बन रहा था? यहाँ से इंफिनिटी से आया और फोकस पे इमेज बना, अगेन आईपीस पे गया and image was getting formed somewhere here like this. So it is not erect, it is inverted, and it is not diminished, it is enlarged. The aperture of eyepiece is smaller than that of objective. Yes, objective का aperture क्या होता है? बड़ा होता है. So A, B and D are correct. Option A will be your correct option. ठीक है, ठीक है. सो तुम लोग मैंने क्वेश्चन कहाँ से ज्यादा क्वेश्चन नहीं आया है रिसेंट ईयर में, वो था तुम्हारा रिफ्रैक्शन से. रिफ्रैक्शन से आया है, अभी अभी स्नेल्स लॉ तक आया है, बट जो तुम पढ़ते हो ना, ये अपेरेंट डेप्थ एंड एक्चुअल डेप्थ में जो डिफरेंस होता है, रिफ्रैक्शन थ्रू कर्व सरफेस, इन चीजों का क्वेश्चन ज्यादा नहीं था, दैट इज व्हाई आई डिडंट इंक्लूड, बट यस यू शुड रिवाइज दिस टॉपिक also, so you can go more back and then you can find some questions, so from there you can practice. If you are not getting, you can practice JEE mains question also of this course. ठीक है, तो प्रैक्टिस करो, कल तुम लोगों का टेस्ट होगा, एवरीवन अपीयर फॉर द टेस्ट, एंड next day we will be discussing wave optics. So wave optics में first I will let you know the whole formula things, क्योंकि that is a bit confusing I know for students. So that thing I will first make clear, then we will do some questions. ठीक है, चलो. If anyone has any doubt, let me know. Otherwise we are going to do. No doubt. चलो ठीक है.